Suppose we have a circuit like this and we need to calculate the currents in the branches. Well, we can use the mesh analysis. We have 3 meshes here and we can solve it. Or we can do a delta star transformation here, and using the equivalent resistance we can calculate the currents using the current divider. So let's try this method. We do the delta star transformation. We transform this delta or this delta as you like. We transform this delta to star. So we have 3 resistance. We call this R3 prime. This one we call it R2 prime, and this one R1 prime. And if you remember, we can calculate R1 prime, R2 prime using the delta star transformation. This one is R2 times R3 over the sum. Here same, R2 prime is R1 times R3 over the sum of the R's, and R3 prime to R1 times R2 divided by the sum of the resistances. Here the resistances are equal, so it's 1 over 3. 1 over 3 ohms. Now we can calculate the equivalent resistance of the circuit because it's easier now. We have this resistor that is in series with this 4, and these two are in parallel. It means that the equivalent resistance is R3 prime plus 2 here, and these that are in parallel. Okay, that's it. That's our equivalent resistance. So R3 prime is 1/3 plus, here we have 1/3 plus R5, which is equal to 1, in parallel with 1/3 plus R4, which is equal to 2. So the value here is, well, let's write it in decimal. Here is 0.333 plus 1.333 in parallel with 2.333. So here we calculate it. 1.333 point, I said point, I write point, 1/3 times 2.333 over 367, 3.67. It means 1.333 times 2.333 divided by 367. This is 0.333 plus 0.8, let's say 5. So it means plus 0.333, we have 1.18 ohms. From here we can calculate the main current. Main current is equal to V over the equivalent resistance. It's 13 over 1.181. So it means we can calculate the first current, 11 amps. Here flows 11 amps. now we have to calculate using the current divider. We'll use the current divider to calculate I5 and I4. I4 will be I minus I5, and I5 is equal to R1 prime, this is the current divider, plus R4 over R1 prime plus R4 plus R2 prime plus R5 times the main current. This is when we have these two resistances are in parallel. That's why we can use the current divider to calculate the current. Here R1 prime is and plus 233, this plus this 2 and 1/3 over 2.333 plus 1.333 times 11. So it means that we have 23333 divided by 367 times 11. This is 7 amps. The current flowing here is 7 amps. Now I4 we can calculate is 11 minus 7, it's 5 amps. Here flows 5 amps. We're left now to calculate the I1. We calculated I5, I4. We are left to calculate I1, I2 and I3. I1 we can calculate this way because the drop here is equal to the drop here plus the drop here. So R1 times I1 is equal to R3 primes times I, the current that flows here, and here flows I5 plus R5 times I5. So it means R3 prime, it's 0.333 times 11 plus R5, R3 primes times, excuse me, it's not R5, it's R2 prime times I5. This is the drop here, R2 prime. So it's 0.333 times 11 plus R2 prime 0.333 point times I5 is 7. So 0.33 times 11, this is 367 plus 0.333 times 7. This is 233.33. So it's 6 amps because I1 is 1, so it's divided by 1. So it means it's 6 amp. Once we have I1, we can calculate I2. I2 is I minus I1. It's 11 minus 6, and it's 11 minus, this is 6, 5 amps. Suppose it's 5, I1 is 6, we're left now I3 that flows this way, plus I1, I3 plus I1 is equal to I5, so it means that minus I1 this is I3. So it means I5, which is 7, minus I1, which is 6. It's it's 1 amp. Okay, so I3 is equal to 1 amp. 1 amp this way, plus 6 gives 7. Okay, this is it. We calculated all the currents flowing in the branches of this circuit. And thanks very much for your attention.